through your code, and I wanted to give you a bit of advice and a bit of feedback on how it's working so far. Okay, so first of all, everything's actually completely correct about this code. Okay, there's only one very small error that we're going to talk about. That's the reason why your program's not working. Okay, the actual structure of your code and the different things that you've written is completely correct. You've implemented Euler's method completely correctly here, so well done on that. Okay, very good job for a first try. The only issue is this time step here. Okay, this dt equals 1. Now remember, Euler's method works better and better the smaller dt is. Currently, you've got the time interval dt set to being 1 second. That's a massive jump in terms of time. Okay, and the reason why you're only getting 2 points, 2 time points in your list for time, okay, is because after 1 second, just 1 second of this program running, your ball goes through the ground. Okay, remember this piece of code here that you've written says that the program only works if the ball is above the ground and if the time of flight is less than 10 seconds. Okay, now we can change this to be however long we want. We can make it 50 seconds if we want. It doesn't matter. The point is that when we set dt to be something massive, okay, this condition here breaks. Okay, and I'll show you how exactly that happens in a second. So firstly, let's run this code with dt equals 1, and I'll show you where it fails. Okay, so firstly, I'm using a program that allows me to execute my code in blocks. Okay, the program is called VS Code, like this, VS Code. You should be able to download it online. It's really useful, okay, because it enables you to execute code in blocks. There's also another website that you can use called Jupyter Notebook. Okay, so Jupyter Notebook that allows you to write code in blocks like this. And the advantage of this is that I can execute each block of code separately. Okay, you'll see in a second. So for example, I can execute this first block like this. Okay, so it tells me that it's successfully executed in 0 seconds. Okay, now I can execute this next block of code separately. So let's do that. Done. And then let's execute your while loop. Done. Okay, and then we'll print out the time points. Okay, so printing out the time points, we see that there's only 2 time points here. Now the last thing I've done, okay, the last thing that I've done here is plotted what your coordinates look like. So all I've done here is I've taken your x points and your y points, and I've put them into a new function, sorry, a new variable called coordinates. And then I've plotted it using matplotlib. I know you've not imported that yet, but I've done it for you here just to show you what's going wrong. If we plot out the actual trajectory of your ball, we see that it immediately goes through the ground. Look at the y coordinate. Okay, it's negative. It's gone through the ground. That's why your program has terminated after 1 step in time. After 1 second, it stopped running. So let's see what happens now if we change dt to be something much smaller. Now remember, this is a computer running, so we can set dt to be really small. Okay, the smaller we set dt, the better it will work. So I'm going to go for 0.01 here, and then let's execute all of this code again. So I'm going to execute this block again, this block again. We're going to print it out, and now before we've even plotted it, look how many time points we've got. So many. Okay, each one of these points is increasing 0.01 in time. Okay, there's a bit of computer error here in terms of the digits. Don't worry about that. But you can see that each point is increasing in 0.01. Okay, and if you look at the end, it stops at 0.48. So in other words, our ball should probably fly for about 0.48 seconds, okay, before it hits the ground. So let's plot the trajectory. Now see, it's working completely. Okay, the only thing I changed was your initial dt. I didn't change anything else in your code. All that I changed was the time step. So that's what's going wrong here. Okay, now to go back, we can also play around with all these variables too. Okay, so for example, let's make the initial velocity much bigger. Let's make it 50 instead of 5 and run again. Okay, we should hopefully get a much bigger array for time. Yes, look. Now look, the ball flies for much longer, 2 whole seconds now. Okay, so if we go back to plotting the trajectory, we should see that the ball reaches much higher. Look at that. Okay, so now it's looking a lot less parabolic. okay? And we can see the effect of air resistance on our ball's motion, yeah? So the only issue is here, the only issue is this dt, okay? We need to make that small when we're using Euler's method, okay? Okay, the last thing is, let me quickly show you how to do this graph plotting, okay, because this is really useful. What we want to be able to do is we want to visualize our results, okay? So let's talk about this code here. So all that I've done in order to plot this curve, okay, is I've created a new variable called coordinates that groups our x points and our y points together, okay? So you can imagine we've got, a whole list of x points in here and a whole list of y points, okay? And I've printed them out just so that I can see what's going on. Oh, my laptop's low on battery. Let me quickly plug it in before I continue explaining. Just give me 1 second. Okay. So, yes, I've printed out the coordinates just so that we can see what it looks like, okay? Looks good to me. Okay, we've got lots of coordinates in here. Now to plot the trajectory, what we need to do is we need to import this Python library firstly, okay? So you need to download it. Now, the way that you can download it is, firstly, we can type this command. So pip install matplotlib, okay? And this will install it for you. So for me, if I run it, we'll see if it installs it. So I've already got it installed, okay? But if you type this command into your console, so into command, okay, so if I type pip install matplotlib, okay, for me it's already done, but you should be able to download it using your command prompt, okay, on your computer. If you're unsure, just look it up online. There'll be a YouTube video somewhere that explains how to do it. Okay, so now we've downloaded matplotlib. We can use this Python library to help us sketch curves. Okay, it's really, really useful. Probably the most useful Python library for physicists, okay, and data scientists. So the way that we get the graph is firstly we do plt.figure. Okay. Now the reason why we use plt is because I've imported matplotlib.pyplot as plt. So this as plt means that every time I want to use this library, I can just type plt instead of typing all of this out. Okay. So each time I want to use matplotlib, instead of typing matplotlib, I'm just going to type plt. So plt.figure creates the graph. Okay, and in here we can change the size of our figure. So if I want to make it square, I can put a 6 here. If I want to make it more of a rectangle, I can put a 12. Okay, for the time being, let's just leave it on the default, which is 10 and 6. Okay, then we plot it. To plot it, all we do is we do plt.plot and we put our x coordinates in the first part. Okay, so x points, y points in the second part, and then we can put a label. Okay, this label trajectory, and you'll see what that does in a second. Okay, so we can label our x and y axis. That's what that does. Okay. Oh no, sorry. That's what this code does here. Okay, plt.x label and plt.y label lets us label our graph axes separately. Okay. So the last thing I can do is my computer's already recommending it to me, but pld.title. Okay. So projectile motion. Okay, so projectile motion with air resistance. Okay, and plt.legend, plt.show. In fact, I don't think we need this. plt.show will present the graph to us. So let's run this code. Okay, there we go. See, now we've got a nice title, okay, on our curve as well. And there are other ways to change the title sizes and all sorts. Okay, you can have an experiment with that just by looking it up online. Okay, just Google matplotlib and have a play around with trying to make the graph look slightly different. But this is the main point. Okay, we can now plot the trajectory and see what it looks like. Okay, now here's one good thing to do. Let's also try and make a graph where we plot the same projectile motion with the same initial parameters, but without air resistance. Okay, so let me show you how you can do that. So for example, you could go back and just set this drag coefficient to 0. Okay, so if I set it to 0, okay, and I run this code, now I run our loop again, print. Now look, it's completely perfectly parabolic. Okay, and I would have to type without error resistance. So we can see that our program works really well now. Okay, our program is working exactly as planned because we know it's correct, because if we plot it without error resistance, we get something that looks perfectly parabolic. Okay, and this is excellent. This is exactly what we want. Hopefully that helps a little bit. So to summarize, all that went wrong is literally just this little dt here. Okay, you might want to play around with how changing dt affects your solution. In fact, we can do that now. Let's change it to 0.5, see if that does anything. Okay, not much difference at all. Let's increase it to 0.1. Again, not that much difference. What if I increase it to 0.5 now? I'm guessing this is where things start to break apart a little bit. Now you can see the parabola is starting to sort of fall apart a little bit. Our steps are a bit too big, okay? And now you can see the curve is not so smooth anymore, okay? If I start to increase this now to say 0.7, it's getting worse and worse. And of course, if we go back to putting it as 1, it gets really bad, okay? And when you put the air resistance back in, so when we change this drag coefficient back to 1, in fact, it breaks completely, okay? Now it's completely broken, our graph, okay? So all that you need to do is make sure this dt is nice and small, so keep it at 0.01, for example, and then your program should work perfectly like this. Hopefully that helped. Just let me know if you've got any problems, and I'll see you soon.